I have strategic oversight of our campus master plan, our landscape master plan, our sustainability initiatives, and most things that are visually exposed. So it's the closest thing to sort of an office of the university architect. And I have architects, landscape architects, interior designers, and planners on my staff. So we touch every project at the early twinkle in the eye phase in the visioning process and try to think big and make an impact. And during this speed dating exercise that we just did, I was telling someone that some of the things we do, and I'm sure you all come up against this, don't make financial sense. But we sort of look at it that, so as the dean mentioned, we're here to educate students. And we have 21,000 students, about 13,500 undergraduates, and the balance in graduate students, and 6,000 employees, faculty and staff, and a bunch of visitors. And if the government has this up way, we'll sort of reduce numbers somehow and all of that. But we want to expose students and visitors to really wonderful things, and then they can take that back to their communities and help make a difference. So this was our, we did a campus master plan in 1997, right after the Olympics, and then it was updated in 2004. And the master plan for us is a very live and living document. And what you see, some of these darker buildings are really just sort of placeholders for future construction. And back in 2004, this is more about campus capacity. But it is a living document. We've done some things right here, the purple, dark purple, were future parking structures. We actually did a parking transportation master plan. We actually did not have the need for that level of density on that portion of campus. And we had our women's softball complex was up here. That land went under contract, so we had to find a new home for them. And this red building used to be a high school, O'Keefe High School, and that was their playing field. And we actually put the women's softball field there. So we actually took the surface parking lot of impervious surface, put it back to really its original use as an athletic field with pervious surface, and gave a really wonderful home for our women's softball program. So the campus, I'll just share a few slides with the growth. Some of you may be familiar with Georgia Tech, but in 1997, we're about 7.5 million square feet and about 12,000 students. Challenging. In 2008, we were about 14.5 million square feet and about 19,000 students. And the master plan went in 2004, sort of looked at 10-year look ahead, and we sort of projected that we would be about 15.5 million square feet and about 22,000 students. Well, if you sort of look at that trajectory growth, we're averaging about 600,000 square feet per year and about 700 people per year. So after a few years, all of a sudden you're larger than a lot of private liberal arts colleges. And but we had a significant growth, and perhaps the leadership was a big part of that. The Olympics put Georgia Tech on the map, and sort of the vision and strategic plan helped change that. Well, we sort of look at sustainability as sort of as most of you do, the three major components: the education, the research, and the campus. And my focus is the campus, but we work very closely with the academic and research communities, trying to have them look at the campus. We have 400 acres, 200 buildings, and use it as a living learning laboratory. So that is their canvas to operate under. Back when Wayne Clough was our president in about 2008 or 9, we had some, or 7 even, we had some deep conversations about whether or not we should sign the American College and University President's Climate Commitment. How many campuses presidents have signed that? So about half here. So it's a challenge, and we had some big debates, and I spoke to Keenan Howard at Emory about this. The challenge for a research university or any university that has a medical school, you can't get to carbon neutrality. It's based on today's technologies. When you have a lot of fuel hoods, you just won't get there. But we figured we're going to sign this. We'll hope that technology changes, and even if we only get halfway there, we're in a better situation than not making this commitment at all. So Wayne Clough signed it, coincidentally, when Bud Peterson came on board. He was on the advisory board of this organization when he was at University of Colorado Boulder, so it made it very easy to continue pursuing these goals. So we sort of approach sustainability, and the master plan sort of is, there are three major components. There's the educational piece, there's ecology, and the economy. And we try to balance these as best we can to be good stewards of all of the resources that are available. One of the unique things about Georgia Tech, I've been there 5 years. I was in private practice. I was with a firm called Lordak and Sargent. I was a principal and a partner there for 21 years. But the unique thing about Georgia Tech, while most campuses have a master plan, very few have a landscape master plan. So the ground plane and the ecological and human landscape is very, very important to us. If you think about people coming to campus, and I'm sure you guys think about it, one of those experiences and memories that people have, it's not a building, maybe there is a building, but it's the pathways and the spaces between the buildings. So we want to think about tree canopy, is one of the themes, and we're creating this eco-common. So what you see in green is about an 80 acres of our 400 acres. And the idea is to visually expose the stormwater so that it becomes an educational, recreational, and research amenity to the campus. And Emory has Low Water Park, which is really sort of a wonderful type of setting. So that's sort of one of the ideas behind this notion. But it's really an engineered waterway, and whether there'll be running water coming through there, that's sort of an engineering challenge. But we've got a few engineers who can kind of help us figure that out. But we want to reduce our stormwater runoff to the way it was in the 1950s. One way to do that is plant trees. Because trees will capture the water, reduce the runoff. So we do a number of tree planting projects and pilot projects. So we sort of think of it as a parkland. So this was an area that we planted about 2 years ago. Now the canopy is filled in. We develop these communities, and things grow quite rapidly. So this is looking out one window of a building to the south, and then to the, well, I guess I don't have it in there, but to the north is an already mature forest. So in about 10 years, this building will appear like it's in the middle of the forest. So, over the past several years, we've executed about 13 major tree planting projects, and we're trying to increase that canopy. And it's hard, we lose mature trees to storms. We do build buildings, we lose and have to sacrifice trees. But in our landscape master plan, we have a tree replacement requirement. And whether it can be on that site or somewhere else on campus, we work with the design team. Because very often, folks in my position at campuses sort of say, okay, I have this project, and here's my piece of land, and the Board of Regents says, all right, what are your site boundaries? Well, as a campus, there are no site boundaries. It's the entire campus, and you really have to look at this integrated network that you have to work with. So what's important, and I'm glad there are staff in this audience today, because we did this pilot tree project. We planted about these 1,200 little seedlings, and a lot of it was with our facilities and landscape services folks. And so here it is, recently planted. And this is what it looked like before it was planted. And 3 years later, we had this very robust forest. And it really is survival of the fittest. We lost some trees. We did have to train our landscape services folks that some of those little seedlings were not weeds and to not use Roundup. But, it is part of the educational process. And then put interpretive plaques, and then you get a couple of unsuspecting students and ask them to pose as if they're reading the plaque to learn about this, our tree canopy and our forestation efforts. But it's also important to sort of think about the existing trees. They won't be there forever, and to begin to plant some understory trees to these types of areas. We want to really look at sort of native woodlands and use eco-mimicry to develop our biomass, and and then you get this variety of trees, with sort of native plants and other trees that then sort of begin to flourish and then create this other canopy. So this was a street, we closed it off, made it a pedestrian walkway, And this was 3 months later, and this we did last year. So another year or two, this street will be covered up in canopy. And as you all know, being in Georgia, walking in the shade is a lot more comfortable than walking in the sun many times of the year. So we actually document. So we have a tree campus inventory, so we know all of our trees, where they are. We've worked with our GIS department on campus to help document that. We try to update it. We do some, it's hard to, it's sort of like painting the Golden Gate Bridge. You just never keep up. Trees die. All of a sudden, some students will want to plant some trees, or we do some other initiative. But we try to keep track of it, and we try to manage it and monitor it. Because otherwise, without monitoring it and benchmarking, you actually have no idea what you're doing. So, through our efforts and our landscape services folks, we applied for and received from the Arbor Foundation, Tree Campus USA dedication. And not only is it about planting trees, but the effective stewardship of those efforts. And it does take a lot, I'm glad there are students here, because it does take a lot of student involvement and participation. So we have a Tree Campus Advisory Committee, and we have a number of students and faculty and staff that sit on that committee to sort of help push this agenda forward. When we look at the stormwater piece, much of the same way you guys do. It rains, we want to capture it, and then how can you harvest that water to recycle it as opposed to a one-time use? Oh, water! Look at that. Very good. Thank you. This is water conservation. So, our landscape master plan sort of looks, as I mentioned, to reduce our stormwater runoff. In Atlanta, we have combined sewers, and so that rainwater gets combined with the sanitary sewer, goes and gets chemically treated and processed, and then goes back into the system, and then we could drink it, or we could flush human waste in a toilet. And I'll talk about that in a moment, which to me is the most bizarre thing in the world. But we're trying, our goal is to significantly reduce our stormwater runoff. One of the things when I came to Georgia Tech, we had a number of cisterns on campus, but it seemed like they were designed perhaps to be fashionable with sustainability initiatives and keeping up with the Joneses, and we'll do a cistern with this project, and how big can we fit, and how much can we afford, and that's what it was. And which is good, it's a place to start. And now we've gotten more mature. Again, I work with our GIS department. We developed a cistern master plan, and my goal is in the next 3 to 5 years is to not use any city potable water to meet our campus irrigation needs. And we're getting pretty darn close. So the areas that you see in blue are all areas that are irrigated with harvested water. And even our football stadium, there's actually an underground stream that we tapped into and have some cisterns over the stands there. The areas you see in red were targets of opportunity as large green spaces that were previously irrigated with potable water. 2 of these, this one right here, and I'll show you, we just did a very large cistern, a 1.4 million gallon cistern in the center of campus. And then our athletic complex, baseball, football, and track, we just built a new football indoor practice facility so that we can do trick plays. If you follow college football, Georgia Tech doesn't pass much historically, so maybe there were some pass plays in there. But if you sort of go by your building site and the lead sort of process, we would only need a 20,000 gallon cistern for that facility. Well, we looked at this entire area. It's about a 7-acre parcel, and we did a 280,000 gallon cistern under the outdoor practice facility. And then what we found out, this is a research building, and there's a 40,000 gallon cistern right there that during the summer months, there was more condensation being generated than we could store. It was just going back into the stormwater system. So we connected these 2 cisterns, and now we've reduced that runoff. So now we'll be able to irrigate all of this, and the payback was about 6 years for that. And then this area right here, this is actually a park, Couch Park, which we don't actually own. It's a city park, but we've sort of adopted it. We've restored it, and we're digging a well right now that will irrigate all that, and our intramural programs use those facilities. So the first project that we actually designed a cistern. So that was for our women's softball. They said, okay, we talked athletics, they need 1.5 inches of water per week, and they want to have a 3-week storage capacity. So, we said we need about 40,000 gallons. So it's actually designed, specifically for this specific site. And this, as far as I know, is the first LEED Gold certified intercollegiate women's softball complex in the country. So, and that hasn't been challenged on that statement yet. But during their little speed networking there, some of us were talking about the drought that's currently going on. And, we had the drought a few years ago, and, the governor, told everybody to reduce your water consumption, and everybody did. Water rates went up because of our conservation efforts. But this was something that, one of our research buildings, a condensation, we just connected a hose down the side of the building, connected it to a tub, and then we would transport that tub to irrigate our critical landscape material. So rather than that, perfectly good water going down into the waste system, we were able to capture it, and that was pretty inexpensive. So we have, right now we have over 2 million gallons of cistern capacity on campus, which is pretty robust, and there'll be several more coming in the pipeline. So in 1996, when we hosted the Olympics, we had the Aquatic Center, and it had the largest PV array, actually in the country, certainly in the country, but certainly on a college campus. We now have the largest cistern on a college university campus. And so this is the center of our campus. How many have been to Georgia Tech besides Carly? Okay, good. So here's our student center. This is our library style, the new Klaus building. Here's our baseball stadium. So this is the Clough Undergraduate Learning Commons, which just finished construction. I'll talk about that. So Georgia Tech never had a central grid space, so we created what we're calling Tech Green. And in that green, we have a 1.4 million gallon cistern that captures stormwater runoff from about a 16-acre basin. And then that water is used, it provides about a 1-month supply of irrigation for sort of the Tech Green and the Clough Commons landscape. It provides about a month's supply of toilet flushing for the Clough Commons and reduces our stormwater runoff by about 60%. And this is actually a BIM drawing that the civil engineer drew, because there's this whole network of stuff that people don't see underground. So this is a city sewer line, there's electrical and communication stuff, so they had to sort of navigate and weave through there to make those connections work. So if you don't know what a million-gallon hole looks like, that's it right there, construction. And here's the building that I'll show you in a moment. So what we try to do is think holistically and integrate architecture, engineering, landscape, technology, sustainability into every single project we do, whether it's a building project, and Jordina is going out to work on a building project now. Pardon?
It's going to be a LEED building.
And that's wonderful. And we can have another whole conversation about LEED, whether that's good or not. I mean, people have been doing sustainable design and construction practices for decades. It's become very fashionable to do LEED, but the students are expecting it, and it's a big marketing ploy, and we're on board with it as well. And it's a good thing, because then you sort of have cocktail talk. So this is the Clough Undergraduate Learning Commons. So we have about a 1-acre green roof on the building here. And I took this photo 2 days ago, and the cistern is under here, and it's sort of interesting. It's about 3 or 4 feet of soil, but the grass is a slightly different color than the other part. And this part was newly planted. It was named for Wayne Clough, who was our president. He's now the executive secretary of the Smithsonian in D.C. So we feel like we taught him well. But so this is so the bottom right is part of the green roof area, and you can see it on the bottom left over here. We have an 85 kilowatt PV array on the roof, and then we have these interactive dashboards that talk and celebrate sustainability. So visitors, students, faculty, staff, this happens to be the dean of the library who is interacting with that. And you can see energy consumption, water consumption, and see how everything operates. So this is the football athletic precinct. So here's where we added this 280,000 gallon cistern that connected to this one up here. And here we just did metal pipes. The one in Tech Green was concrete. So we investigate different types of materials. Some are above ground. We were renovating our Alexander Memorial Coliseum. And so here's the softball complex right here. That cistern is right back there. And here we have a stormwater detention basin that's visually exposed that will sort of educate people, and we'll have an interpretive plaque there to celebrate this. We'll have native plant material in there, and about 85,000 gallon capacity. We had 6 of these cisterns under one, under the stands of the east stands of the football stadium. We added 6 more, and this stuff is cheap. It's really inexpensive, and this is tapping into an underground stream. So there are a lot of different strategies, and you guys probably are doing a lot of these things. You want to capture the rainwater. We have a CalSans system for our irrigation, so when it's raining outside, our irrigation system isn't on. Using native plant materials. Our dining halls have been, Sodexo is our vendor, and they've done some wonderful, wonderful things working with the campus to sort of help move their agenda forward and working with the students, going trayless. I know Kennesaw, we were talking that, when you go trayless, it's less food waste, less use of water, all these things. And the other thing, just from the physical plant side, we have leaky pipes, and so we've invested in this infrastructure because it's huge. And what sort of helped trigger this was our facility plant director cut a piece of steam pipe, it's about 1 foot long, and gave it to our executive vice president for administration and finance, and it looked like Swiss cheese. And he showed that to the president, and we had steam coming out of the ground constantly. So he said, we've got to fix this. So we were able to do that. But our water use has gone down, even though our research programs have gone up because of changes in behavior. And it's a constant educational process. We have students coming in, as all of you do, so you lose, depends whether on a 4-year, 5-year, or 6-year plan, but you lose a large percentage of them every year. But faculty, staff too, there's turnover, we have to continually educate folks. Because we have to make people accountable. They're not paying the bills, as they do in their own homes. So they leave the water on when they're brushing their teeth, they'll leave the lights on when they leave a room. But now we're changing that behavior. And then just a couple other slides about renewables. There's another new building that we have under construction right here. We actually got federal stimulus money from the National Institute of Standards and Technology. This is a research building, and the focus is carbon neutral energy solutions. So when we're done with this building, it will be net zero energy from day one. It excludes a lot of the heavy research plug loads, but a few computers and all that will be fine. And their focus is pilot scale research on engineered systems and products. So here's what that building looks like. Just some visual bling there. That's PVs, and we looked at geothermal. It didn't make sense, but we do have a cistern, and it's on a portion of campus called North Avenue Research Area. Here's North Avenue. The main campus is up here. Coca-Cola is just to the east. And then we looked at opportunities going down the road. Where might we install PVs in the future? So we looked at roofscapes where that might be able to occur. It's very expensive in today's technology. That technology will change, be more affordable, and that will make investments just because it's the right thing to do. So the key things, we have to act holistically and really think hard, engage all of the folks around the table and beyond to participate in the conversation. Think beyond your site boundaries. Your boundary is your campus, and it may even go further than that. So you have to think big. You need to demand that people are thinking interdisciplinary. When we hire architects, the landscape architect and the engineers are equally as important in the selection process as the architect. And I think that's very, very important. So, and you want to expand that, you want to get development and philanthropy involved, because we have to find alternative funding sources, get the students involved. Some of you might have green fees where students are chipping in some money and begin to make incremental progress, and that's very important. And then this is my last slide, so some of you may be familiar with this. This is Ground Zero, and this was actually designed by an architect, Michael Harrod, who studied at Dartmouth, went to graduate school at Georgia Tech, got his master's in architecture degree, and I tell him I'm partially responsible for his success because he interviewed with me at Lorac and Sargent. I didn't hire him. He moved to New York, and he now has international fame.
But the final design was refined by a landscape architect.
Well, he collaborated with Peter Walker, so that they were the team. So, but it was continual refinement. I agree. And then a lot of politics as well. So, anyway, that's my story.